Information structures also differ, and bidders may have different information about the values of the items themselves. There could be perfect information where everyone knows everything. However, it's more likely to have situations such as independent private values, where you have a number that you know yours, but you don't know what other people have as their numbers. Or there might be an affiliated or correlated value estimates, where there's some consensus value. And by watching others, you can see where that emerges. And there's a special case, which is called a common value auction, where the common value to all is unknown. And we're just trying to estimate what that might be. And the case here would be an oil auction, where we're auctioning off the mineral rights to what's underneath the ground. And those are examples of a special case called common value. How would we handle conditions where there is an independent private value? In the case of an English auction, you remain active until the price exceeds your valuation, then you stop. In the second price sealed bid auction, you bid your valuation. It can't hurt you, because if you won the bid, you wouldn't pay that. You would pay the second price. And the third case is first price or sealed bid auctions, and that's strategically equivalent to the Dutch auction. So in these cases, bid less than your valuation. If there are n bidders that are participating, and they all have perceived values that are evenly distributed from high to low, then the optimal bid, B, follows this formula. You take your own valuation, V, and you subtract from it V minus L, where L is the lowest and H is the highest bid, divided by N. And what you see is as N goes up, in other words, more and more bidders, the second term there gets closer and closer to zero. So you eventually going to bid your own anyway. But if there are very few people bidding, then you may be able to get a discount or a reduction from your high bid. That's why it's V minus, right? So you have your number, and it may be lower depending upon the competitiveness and the variation of values that are sitting in that room. Let's try this out with a problem. So consider an auction where bidders have independent private values. Each has valuations that are between 1 and 10. Sam knows his own value, and it's 2. Determine what is Sam's optimal bidding strategy in these conditions. First price sealed bid with 2 bidders. Second, a Dutch auction with 3 bidders. And third, a second price sealed bid auction with 20 bidders. Let's answer that question. So first, we have Sam in a situation where there's an auction that's first price sealed bid. And that's where we use the formula we just looked at, which is the bid equals Sam's value, 2, minus Sam's value minus the lowest, 2 minus 1, divided by number of bidders. So Sam, although willing to pay $2, will bid $1.50. Next is if we're in a Dutch auction, we have 3 bidders in this case. So it is 2 minus 1 divided by 3 equals $1.67. Notice that it went up because now there are more bidders. Next alternative is where it's the second price sealed bid auction with 20 bidders. In this case, you bid your true value, which is $2. Let's try a different scenario. This is where there are correlated values. They're not independent, they're correlated. So you can watch other people. The thing we're afraid of is what's called the winner's curse, where you win, but you feel that you made a mistake because you're looking around like, why didn't other people bid high? And this is where there's this fear from correlated values. Like, am I the only one that overvalued? To avoid this, the bidder should revise downward your bid so you're not caught, embarrassed, and hurt by overbidding. And we may also see in the process that you determine some information that may help you. Where we are most vulnerable is when we're in sealed bid. We have an envelope, we have to put in a piece of paper with our number. We have no information about the other's valuations, which is quite different in an active, what we call outcry auction. If it's an English auction, you could watch and see who's bidding and when people drop out. And therefore, if it's seemingly very high demand, hotly contested, you may have to move up your valuation. If it seems fairly lackluster and not particularly interesting to the bidders, you may be able to save some money. So correlated values is very useful if you can watch what they're doing. Otherwise, you're kind of shooting in the blind, and therefore you're vulnerable to the winner's curse. If you're the auctioning party, what can you expect from different types of auctions? And here we have the conditions again of information being independent private versus affiliated value estimates. If it's independent private values, English is equal to second price, which equals to first equals Dutch. So as an outcome for you as the seller, you would expect the same across the four. Where you'll see a difference is in the affiliated value. The English and second price will yield higher values to you than first price or Dutch. Summarizing Chapter 12, we looked at different strategies to manage risk and uncertainty using statistical measures and looking at optimal search strategies. We calculate the profit maximizing output and price in an environment with uncertainty. We explain why asymmetric information structures and incentives. See how bidders construct their optimal strategies and what types of actions are dictated by either information that is independent or correlated/affiliated.